The last section in consumer math is section 10.6 in our book, and it deals with ordinary annuities, sinking funds, and retirement investments. An annuity is an account into which or out of which a sequence of scheduled payments is made. An ordinary annuity is one in which equal payments are made at regular intervals with the interest compound at the end of each interval and with a fixed interest rate for each compounding period. And this is called an ordinary income annuity or a fixed annuity. The amount of money that is present in an ordinary annuity after T years is known as the accumulated amount or the future value of an annuity. To determine the accumulated amount, we could use a computer to generate a spreadsheet as seen on the next slide. And if you purchase an annuity, they will give you a sheet like this that will show you. It's kind of like the amortization schedule for a mortgage, but they'll also give you one for an annuity. Another way, and perhaps a more efficient way, to calculate the accumulated amount is to use the ordinary annuity formula on the next page. And this formula here is the one that we're going to use as we work through the problems in this section. And A is the accumulated amount, P is the payments of P dollars that are made N times per year for T years at a certain interest rate R, which is given as the decimal, and it's compounded at the end of each of the payment periods. So let's try an example. Bill and Megan are depositing $250 each quarter into an ordinary annuity that pays 4% interest compounded quarterly. Determine the accumulated amount in the annuity after 35 years. So the payments are $250. They're made quarterly, 4 times a year, so N is 4. 35 years is T, and the interest rate is 0.04. So there's the ordinary annuity formula, and we're going to go ahead and substitute in the values that we have for the payment, $250, the interest rate, 0.04, 4 payments per year, and then 35 years. And if we go ahead and simplify inside the parentheses, let me just go back for a minute. Remember to start here, so take the 0.04, divide by 4, that's going to give you 0.01, and add it to 1. So you get 1.01, and it's raised to the 140th power. Remember, 35 years times 4 payments per year, minus 1, and then divided by the interest rate divided by the number of compounding periods in a year, 4, so 0.01. And then furthering simplifying, if we raise 1.01 to the 140th power, we get this number. Next step, we're going to subtract the 1, then we're going to multiply by the 250, and finally the last step will divide by 0.01. So in 35 years, they'll have $75,677.48 approximately. We've done a little bit of rounding with our decimals, but that's a pretty good approximation of how much they'll have accumulated. Another example, use the ordinary annuity formula to determine the accumulated amount in this annuity. We're doing $1,000 invested semi-annually, that means twice a year, for 20 years at 5% interest. So our payment is $1,000, the interest rate is 0.05, 2 compounding periods per year for 20 years. Use the ordinary annuity formula, substitute in the values that we were given. Again, we're going to start right here. 0.05 divided by 2 is going to give us 0.025. Add it to 1, it's going to be raised to the 40th power. And in the denominator, we also have that 0.025. Next step, we're going to raise the 1.025 to the 40th power. Next step, we're going to subtract 1 from that figure. We're going to multiply the numerator, that's figure times 1,000. And finally, we're going to divide by 0.025. So at the end of the compounding period, we'll have about $67,402.55 after 20 years. The ordinary annuity is used when you wish to determine how much you're going to accumulate when you contribute a fixed amount. A sinking fund is used to determine how much an investor needs to invest each period to reach a certain goal. A sinking fund is the type of annuity in which the goal is to save a specific amount of money in a specific amount of time. And so we have a payment formula for the sinking fund. So the payment is given by this formula, how much we want to accumulate. R is the interest rate as a decimal, N is the number of compounding periods, and T is the time period. Notice that the parts here are similar to what we used in the prior formula, but this time we solved for the payment rather than solving for the accumulated amount. So let's try an example. The Burnett's would like to have $55,000 in 10 years to purchase a travel trailer for camping. They decide to invest monthly, so that's 12 periods per year, in a sinking fund that pays 3.3% interest compounded monthly. How much should they invest in the sinking fund each month in order to accumulate that $55,000 in 10 years? So the amount we want to accumulate is $55,000. The interest rate as a decimal is 0.033. Monthly compounding, monthly payments, so N is 12, and they're going to save for 10 years. So there's the formula for the sinking fund payment. We're going to put in the values that we have for our problem, 55,000, 0.033 interest rate over 12 for the number of payments. Similar to what we've seen in the prior formula, we've got the 0.033 over the number of payments per year, and then it's going to be raised to the 12 times the 10. Now again, on this one, I would start within those parentheses to simplify those quantities there. And so what I did here was I divided 0.033 by 12 and then multiplied by the 55,000. Down here, I took 0.033 divided by 12, add 1, raise it to the 120th power, and subtract 1. So here's my numerator and denominator. And my last step, I'm going to divide, and I come up with 387, about 45, actually 48 rather. We're going to round it up to 49. If you go back and look, it was a little bit more than 48 cents. And so we want to make sure they have their goal of 55,000, so we're going to go ahead and round that up. And we might even want to round it up to the next dollar to be sure that we meet that goal. Let's try another problem. Use the sinking fund formula to determine the payment needed to accumulate $1 million using a quarterly payment, 10% interest for 40 years. So the amount we want to accumulate is $1 million. The interest rate is 0.1, 4 periods per year for 40 years. So we use our sinking fund formula, substitute in our values. Again, I would start here, divide 4 into 0.1, which gives you 0.025, and multiply by $1 million. Likewise down here, 0.1 divided by 4, add to 1, raise to 160th power, and subtract 1. So I end up with 25,000 divided by this figure. And the last step, I do the division, and I come out with $490 and about 41 cents. So for 40 years, interest rate of 10%, if we contribute this quarterly, we'd be able to accumulate $1 million. Variable annuities are annuities that are invested in stocks and bonds, etc., other investments that do not provide a guaranteed interest rate. Everything we've done up until now was a fixed annuity. The interest rate was guaranteed for the period of the annuity. This term variable here is used because the value of the annuity will vary depending on the performance of the investment options chosen by the investor. Like in an ordinary annuity, the investor usually invests in a variable annuity by making regular periodic payments. However, the variable annuity does not have a fixed rate of interest. An immediate annuity is an annuity that is established with a lump sum with the purpose of providing the investor with regular, usually monthly payments for the rest of the investor's life. In exchange for giving the investment company the lump sum, the investor is guaranteed to receive the income for the duration of the investor's life. Obviously, there's a downside to this. If the investor doesn't live very long, that lump sum is lost. Individual retirement accounts, which were also referred to as IRAs, are savings accounts that allow individuals to invest each year for the purpose of saving for retirement. They have distinct tax advantages over ordinary savings accounts. There are two types, and they can generally be classified either as a traditional or as a Roth IRA. A traditional is one in which pre-tax money is invested, meaning that any money invested is not subject to tax at the time you invest it. However, when you withdraw it, you will be subject to taxes. The Roth is the opposite type of IRA, in which you pay tax on the money going in, post-tax money is invested, but then you withdraw the money, you don't pay any taxes. 401ks are retirement plans that allow employees of private companies to make contributions. Again, the important feature on this one is pre-tax. So they're pre-tax dollars that are then pooled with other employees' money. And then the funds are invested in stocks and bonds and so forth. And many companies allow the employees to choose how the investments are done. So they have several distinct advantages. Employees are generally allowed to invest more money in a 401k plan than in an IRA. And often they're eligible to invest up to 15% of their annual income. And many employees also will match the contributions up to a certain point. So that's a real advantage for the employee. It's like getting free money. The Roth 401 plan is this retirement savings plan that differs in the investor first pays the income tax on the money, like we talked about with the Roth IRA, and then when the money is withdrawn, there is no the money is not subject to income tax. And 403Bs are similar to 401Ks, but these are available to employees of public agencies, schools, civil government, hospitals, and other non-for-profit organizations. And they have many of the same advantages as the 401K plans. These are not necessarily established by an employer. So 403B can be run by an independent company, whereas the 401K is run by the employer himself or herself. It's frequently established independently. There we go. So in summary, as you can see from this brief discussion of different kinds of investments, there's many important decisions and details that can affect your decisions as you begin to invest for retirement. For more information, you should consult a financial advisor or visit a library or internet website for additional information. Regardless of the source of your information, it's important that you do your research and ask questions before you invest.